All right, we're going to do my nomials. We're talking about raised to a power. Before we've done multiplication and division, for example, when I had here 5 raised to the 3rd power times 5 raised to the 6th power, okay? That was essentially 5 to the 3 plus 6 power, which is 5 to the 9th power, and then we put it in our calculator and solve for it. It's like 59. Well, what if we have 5 raised to the 3rd power cubed? Outside is in the parentheses we have raised to the 6th power. So 5 cubed raised to the 6th power. What this one is a little different. This is 5 cubed times 6. When we have the parentheses, we're multiplying the exponents now. We're no longer adding. So this is 5 raised to the 18th power. So when we're multiplying the same base, we add their exponents. But the minute you see a parentheses and you see an exponent raised to a power, you're supposed to multiply the exponents. Let's look at another example. So if I have a to the 4th times a to the 10th, we were doing a to the 4 plus 10th power, which is a to the 14th power. Well, if I have a to the 4th quantity 10th power, because I have these parentheses and the exponents on the outside, now we multiply. This is a to the 4 multiplied 10, which is a to the 40th power. Please do not get these two confused. If I'm multiplying and everything's on the outside of the parentheses, I'm going to add the exponents. But the minute I put the exponent on the outside of the parentheses, then there's a difference. I need to multiply. Here's one more example. I may do something like this. B squared times b to the negative 3rd power. I might do parentheses like that. Well, what is the exponent? Remember, when there's no exponent or no number written there, it automatically means to the 1st power. So, really what we're doing, this is the same thing as b squared times b to the negative 3rd power. And what do we do on this one? We add the exponent. So, same thing here. B squared plus a negative 3. Come on in there, negative 3, which is b to the negative 1st power, which just means it should go to the denominator, 1 over b to the 1st power, but we don't write a 1st power. Same thing here. These two are the same. I'm trying to get you to understand that this set of parentheses, a to the 4th raised to the 10th, is not necessarily the same as this one, because there's no exponent outside. Both of these exponents are in the inside here. Therefore, we're going to do what we did old school and just add them there. So this again, this is the same as that. This is b to the 2nd plus negative 3, excuse me, which is b to the negative 1, which is b, 1 over b. All right, so the next portion, I'm going to move kind of fast. You're going to have to hit pause as you need to. This portion is very easy, like the addition and subtraction, but now we're multiplying exponents. When you raise a power to a power, you're going to multiply your exponents. So here's our first example. I have here 5m cubed, all of that raised to the 4th power. Okay? What power is that? 5. Remember, we don't go around putting numbers in. We already understand this to the first power. I have to distribute this 4 to the 5 and to the 3 where the m is. So this is going to be 5 to the 1 times 4 power, m to the, there's already a 3 there, m to the 3 times 4 power, which is 5 to the 4th, m to the 12th power, which is 625 m to the 12th power. 5 to the 4th is 625. Another way you could look at this is the same thing. They're saying when you raise it to the 4th power, that means you're going 5m cubed times 5m cubed times 5m cubed times 5m cubed. That's the expanded way. You're doing it 4 times. Okay? 5 times 5 times 5 times 5 is still going to be 625, or 5 to the 4th. And then you know when we have these m's here, we're adding them together, it's going to be m to the 3 plus 3 plus 3 plus 3 power, which is m to the 12th power. Alright? Let's look at the next one. Example number 2, we have 8t squared v to the 7th, all of that raised to the 5th power. We must distribute, and I won't even write the word distribute, the power to everything on the inside of the parentheses. So this 5 goes to the 8 to the 1st power, the 5 goes to that square, and that 5 also is multiplied by the 7. So this is 1 times 5, which is 5. 2 times 5 is to the 10th for the t, and then the v is 7 times 5 is 35th power. 8 to the 5th power is 32,768. To the t to the 10th, v to the 35th power. Example number 3, excuse me. So here I have, and I probably need to move this over a bit. Let's see if my computer will go. So here we have example 3, 6 r to the 4th cubed raised to the negative 2nd power. Well, again, we still don't like negative exponents, but we can distribute that. Distribute this negative 2 to the 6, to the 4, and to the 3. So 6 to the 1st power would be 6 times negative 2, which is 6 raised to the negative 2 power. 4 times negative 2 is r to the negative 8. 3 times negative 2 is u to the negative 6 power. Okay, we don't like negative exponents, so what does that mean? That means everything needs to go to the denominator. So here it is. That's going to be 1 over 6 squared, r to the 8th, u to the 6th. Everything became positive because all these exponents were negative. We did the opposite, we just put them in the denominator because they were already in the numerator. 6 squared is 36, r to the 8th, u to the 6th power. And that's your answer for example number 3. Let's look at example number 4. Example 4, come on, example 4. Alright, so we have here 4m to the negative 2nd power n cubed raised to the negative 4th power. Well, this negative 4 has to be distributed to everything. Okay? This 4 is raised to the 1st power. 1 times negative 4 is 4 raised to the negative 4th power. Negative 2 times negative 4 is the 8th power. N to the negative 3rd, or positive 3rd power, excuse me. 3 times negative 4 is going to be a negative 12. Okay? I don't like negative exponents, so that means the 4 and the n need to go to the denominator because they have negative exponents. M will stay in the numerator, so it's going to be m to the 8th. 4 to the 4th power in the denominator, n to the 12th power, because we want that negative 12 to become positive by putting it in the denominator. 4 to the 4th power is 256, so it's going to be m to the 8th divided by 256 n to the 12th power. Next example. Example number 5. We have 3p raised to the negative 4th, r to the negative 7. Okay, and I have this written to the negative, raised to the negative 2nd power. And again, we need to distribute this, okay, to everything inside, even the denominator. So how do I have that? It becomes 3 to the negative 2nd power. Negative 4 times negative 2 is a positive 8. Over negative 7 times negative 2 is a positive 14. The only thing that's negative is that base 3, and we're going to do that by taking it to the denominator. So p to the 8 stays in the numerator. 3 squared r to the 14th is in the denominator. And then, of course, 3 squared is going to be 9. So we have p to the 8th divided by 9r to the 14th power. Example number 6. Again, I have a negative exponent. Okay? I to the 4th, h to the negative 3rd, divided by r to the 5th. All of that is raised to the negative 2nd power. Again, you have to distribute this to everything in the parentheses there. Okay? How do we do that? That's going to be the same thing as. This is another way to do it. The minute I see a negative exponent, it automatically means everything should flip. So that means that the r will come to the numerator, be positive 5. It will remain the same, I to the 4th, h to the negative 3rd. But look what happens to the exponent if I decide to do it that way. Now our negative 2 becomes a positive 2. So this time, what I did was take the numerator, put it in the denominator, put it in the numerator, and that automatically changes my exponent from being negative to positive. Okay? So I can switch them like that, or I can do what I did up here and just distribute it, and once I finish distributing, flip it at the end. So you can either flip or take the reciprocal at the beginning, or you can do it at the end. This time we decided to take the reciprocal at the beginning. Let me take that out of there. So here it is. R to the 5th, I to the 4th, over H to, R to the 5th divided by I to the 4th, H to the negative 3rd. Again, our exponent becomes positive now because we take the reciprocal of the entire fraction. All right, so here we have distributing now, we have this here. R to the 10th divided by I to the 8th, H to the negative 6th power. We don't like that negative 6, so that means that the H to the negative 6 needs to go now back up to the numerator. And we're going to have H to the 6th, R to the 10th, and an I to the 8th power. Why is H in front? Because H comes before the R divided by I to the 8th power. And we will stop there.